For this video, we're looking at indeterminate forms. So let's suppose that you took a limit and you got 0 over 0. We already know that we can resolve this because we have a common factor that you can either reveal by factoring, canceling, or maybe you're having to multiply by a conjugate or something. Or you could have gotten infinity over infinity that we might be able to take care of by dividing by the largest power of x in the denominator or thinking about dominant terms. But what these both meant was that there was more work to do. Now imagine you took a limit and you got infinity minus infinity. Well, we don't really know what that is. It's indeterminate. 0 times infinity, remember that this isn't really necessarily 0. It's something really, really small times something really, really large. So it's unclear what's going to happen. If you have 0 to the 0, unclear. This one bothers some people, 1 to the infinity, but remember that this isn't really 1. It's something really, really close to 1 because you're taking a limit. So every little decimal, when you start multiplying and have something exponential, could really matter. Or finally, infinity to the 0 power. So these are all indeterminate, meaning that we don't know just by looking at them what they're going to be equal to. It depends on how we got them. What was the original equation that you were taking the limit of? So one nice thing that we have is we have something called L'Hopital's rule. So L'Hopital's rule, there's a little hat, says that if you take the limit, and let's say as x approaches a and you have two functions, f of x over g of x. Well, if you get an indeterminate form of either 0 over 0 or infinity over infinity, and let me just emphasize, it's only these two cases. If you get one of these, now if you have a positive or negative multiplied in here, that doesn't matter. But it has to be 0 over 0 or infinity over infinity. Then you can apply L'Hopital's rule, which says that this limit is equal to the limit as x approaches a of f prime of x over g prime of x. Now, don't apply this if the limit is not 0 over 0 or infinity over infinity because it won't be correct. And you can look up videos for how this works, but you actually have some things cancel out when you have the 0 over 0 infinity over infinity. So we're just going to look at applying L'Hopital's rule. So let's say that you start with the limit as x approaches 0 of e to the 3x minus 1 over x. Your first step in a limit is to actually just plug in. So I would have e to the 3 times 0 minus 1 over 0. Well, I know e to the 3 times 0 is e to the 0, and e to the 0 is 1, so 1 minus 1 is 0 over 0. So because I got 0 over 0, I know that I can apply L'Hopital's rule, which says that I can do the derivative over the derivative. Now, why would I do that over something else? Well, if you look at this, there's nothing I can factor out to cancel. There's no conjugates, nothing. So this is one way out. So I'm going to do the limit again. But I'm going to do it of the derivative over the derivative. So the derivative of e to the 3x is 3e to the 3x. This is your u, 3x, and our u prime is 3, so I'll bring that out. The derivative of a negative 1 is 0. The derivative of x is 1. So I already know that I won't be applying L'Hopital's again because I'm not going to have a 0 in the denominator. But now I take the limit, so this will be 3e to the 3 times 0 over 1, which is 3. Then e to the 3 times 0 is really e to the 0. E to the 0 is 1, so the answer is just 3. So we have an answer after one application of L'Hopital's rule. So take a look at this next problem. You have the limit as x approaches negative infinity of x squared over e to the negative infinity. I'm sorry, e to the negative x. So if I plug in negative infinity right now, I get infinity, negative infinity squared, which is infinity, over, take my negative infinity, plug it in, and that's an e to the infinity. Well, e to the infinity is infinity. So I have infinity over infinity. That's one of the two cases I can apply L'Hopital's rule with. So I'm going to take the limit again. But I'm going to do the derivative over the derivative. So the derivative of x squared is 2x divided by the derivative of e to the negative x is a negative e to the negative x. This is u sub. My u would be equal to negative x, so my d would be, and my u prime would be a negative 1. So I'm going to evaluate the limit again. 2 times negative infinity is a negative infinity over, and then if I look at this, I'm taking negative infinity, the opposite of it, so that's infinity. E to the infinity is infinity, but it's negative, so a negative infinity, which is the same as infinity over infinity, which is still indeterminate. So you might not think I made progress, but you'll notice the power went down. So if I do this again and take another derivative, I will be down to the number 2, which means I won't have to do L'Hopital's again. So I'm going to do the limit as x approaches negative infinity. The derivative of 2x is 2 over the derivative of e to the negative x is a negative e to the negative x times a negative 1, so a positive e to the negative x. So I look at this, reevaluate my limit, and I have 2 over, take my negative infinity, plug it in, negative infinity times a negative 1 is infinity, e to the infinity is infinity. 2 divided by something really, really huge goes to 0. So the answer to this question is 0. And that would be 2 applications. I'll do more examples in the next video.